Good morning, students. Chapter 7, Alternating Current. In last lecture, we have discussed about transformer. What is transformer? Requirement, principle, construction, and then working of transformer. Okay, and with this, yes, theory is over. Now we will see questions based on alternating current. Okay, see, example 7.1. One bulb is rated as 100 watt, 220 watt supply. You have to find what is resistance of bulb, what is maximum or peak value of voltage, and what is IRMS current. Now see, first of all, in question of AC, that is alternating current, if you are given voltage supply, that is here 220 volt supply, means it is RMS value, means it is RMS value. So here this bulb is rated as 100 watt, means power P is equal to 100 watt. 220 volt supply means it is value of VRMS. VRMS is equal to 220 watt. Okay, and now questions are, you have to find what is resistance, what is maximum value of voltage, and what is IRMS current. What is IRMS current? Okay, so first of all we will find resistance. Yes, first equation that we have to use. Power P is equal to, it is V square RMS upon R. So therefore R is equal to, it is V square RMS upon P. V square RMS 220, it's square, divided by power, that is 100. You will get your answer. Okay. Second question that you have to find, Vm, that is maximum value of voltage, below perturbation, that is Vrms is equal to Vm upon root 2. So therefore Vm is equal to, it is root 2 Vrms. So it is answer of second question. Third question, what is IRMS current? Yes, power P is equal to, it is IRMS and VRMS. Why only IRMS, VRMS? Where is cos del? Where is cos del? Here bulb means only resistor. Bulb means only resistor. And yes, in case of resistance, phase difference del is equal to 0. So cos del is equal to 1. That is power factor is equal to 1. Yes or no? Yes, it is. Okay, so what is equation of power? P is equal to IRMS, VRMS. Then how to find IRMS? Yes, IRMS is equal to P upon VRMS. P upon VRMS. Clear about this? You have value of P. Yes, you have value of VRMS. You can easily calculate this. Okay, see, students, in this chapter, okay, you have to remember equations, just equations, and yes, it is based on calculation. Okay, second question, example 7.2. What is example 7.2? See, here you are given one pure inductor. Having inductance L is equal to 25 millihenry. It is connected with source of 220 volt. You have to find what is inductive reactance, what is IRMS, frequency is given, that is 50 Hz. So, see, first of all, L is equal to 25 into 10 raised to minus 3 Henry. Source of 220 volt means it is VRMS. VRMS is equal to 220 volt. Okay? First question is, you have to find inductive reactance. So, yes, we know that inductive reactance XL is equal to XL is equal to omega L is equal to 2 by FL. 2, that is 2 by 3 by 14. F, frequency you are given 50, and L, it is also given. So first question is easy. Yes. Second question, that is, what is IRMS? Yes, what is equation of IRMS? IRMS is equal to VRMS upon XL. See, it is only inductor circuit. So obviously, IRMS is equal to, it is VRMS upon XL. VRMS upon XL. You are given value of Vrms, XL from first question. Okay. So yes, for inductor it is IRMS. Yes, you have to find two questions. What is inductive reactance and what is IRMS? Clear about this? Okay. So yes, it is example 7.2. Next one. Example 7.4. You are given a capacitor having capacitance C is equal to 15 microfarad is connected to a source of 220 volt and 50 hertz. Okay. You have to find what is capacitive reactance, what is IRMS and what is IM. Another question is, if frequency is double, then what happens with capacitive reactance and current? First of all, we will identify data. C is equal to 15 microfarad means 15 into 10 raised to minus 6 farad is connected to or is supplied to 220 volt 50 hertz means Vrms is equal to 220 volt and frequency F is equal to it is 50 hertz. It is 50. Okay. So yes, first question A. First thing you have to find capacitive reactance. Yes, capacitive reactance. How to find capacitive reactance? Capacitive reactance Xc and Xc is equal to it is 1 upon omega c is equal to it is 1 upon 2 pi Fc. Simple. It is 1 upon 2 pi Fc. Yes. Xc is equal to 1 upon omega c is equal to 1 upon 2 pi Fc. 2 given pi given F. Yes, given C is also given. You have to calculate this. Okay. Second question. What is IRMS? Yes, IRMS. Again, IRMS is equal to it is Vrms upon Xc. IRMS is equal to it is Vrms upon Xc. Simple. In case of resistance, only resistance, IRMS is equal to Vrms upon R. In case of inductor, IRMS is equal to Vrms upon XL. In case of capacitor, IRMS is equal to Vrms upon Xc. Simple. Okay. Yes. Third question. What is third question? You have to find what is value of Im. So again we have one relation, that is IRMS is equal to Im upon root 2. So therefore Im is equal to root 2 IRMS. It is root 2 IRMS. Clear about this? So yes, it is about question about capacitor. Now what is question B? What is question B? Yes, what is question B? See, if frequency is doubled, then capacitive reactance and current. Frequency is doubled. See, capacitive reactance Xc is equal to 1 upon omega c is equal to 1 upon 2 pi Fc. 2 constant, pi constant, c constant. F is doubled. What is relation between frequency and capacitive reactance? Inversely proportional to. So here I can say Xc is proportional to 1 upon F. So if frequency is doubled, if frequency is doubled, okay, frequency is doubled, then Xc, it becomes half. It becomes half. Simple, because they both are inversely proportional to each other. They both are inversely proportional to each other. Any doubt? Okay. Another one, reactance and current. Yes. What is the relation between current and Xc? So again I can write IRMS is proportional to 1 upon Xc. So now Xc becomes half. Xc, it becomes half. So IRMS becomes double. IRMS becomes double. Clear about this? So yes, it is relation. Any doubt? Okay, yes. In case of inductor, XL is directly proportional to F, means inductive reactance is directly proportional to frequency. But in case of capacitive reactance is inversely proportional to frequency. Yes, it is inversely proportional to frequency. Clear? So yes, we have three questions. First, based on only resistor. Second, based on only inductor. Third, based on only capacitor. Clear about this? Okay, you have to remember equations. Now next example. Now next question. See, show that in the free oscillations of LC circuit, the total energy is constant in time. Total energy means energy stored in capacitor plus energy stored in inductor, it remains constant. See how to solve this question. Let charge on capacitor at time t is, let charge on capacitor at time t is Q is equal to Qm cos omega 0 t. Okay, so therefore energy stored in capacitor UE is equal to, it is Q square upon 2C is equal to, it is Qm square cos square omega 0 t divided by 2C. Simple? Okay, here's equation number 1. That is equation number 1. Now, it is equation of charge. What is equation of current? So, yes, at time t, current in inductor, if you differentiate this equation, you will get equation of current. I is equal to, it is minus Qm omega 0 sin omega 0. Simple? Yes, it's simple. Okay, then what is energy stored in inductor? Therefore, energy stored in inductor, UB is equal to half Li square. It is half L. I square means square of this equation, means it is omega 0 square Qm square sin square omega 0 t. Any doubt? Any doubt? Okay, yes. Now we know one relation. Which relation? We know one relation. Yes, okay. At some particular frequency, that is omega 0. Omega 0 is equal to, we know it is 1 upon under root LC. Yes or no? Omega 0 is equal to, we know that it is 1 upon under root LC. So if you take square on both sides, omega 0 square is equal to 1 upon LC. So therefore, omega 0 square L is equal to 1 upon C. Yes or no? Omega 0 is equal to 1 upon under root LC. So omega square is equal to 1 upon LC. So omega 0 square L is equal to 1 upon C. So here, this L omega 0 square I will replace by 1 upon C. So what is UB? Yes, UB is equal to, it is half as it is. L omega 0 square is replaced by C, which is divided by C. And in numerator it is Qm square sin square omega 0 t. Simple? It is equation number 2. Any doubt? So now what is total energy? Yes, how to find equation of total energy? So therefore, total energy U is equal to UE plus UE is equal to UE, here it is Qm square cos square omega 0 t divided by 2C plus UE, it is Q square m sin square omega 0 t divided by 2C. Simple? So is equal to, it is Q square m upon 2C common. Q square m upon 2C common. In bracket, it is cos square omega 0 t plus sin square omega 0 t. Cos square omega 0 t plus sin square omega 0 t. And we know that sin square theta plus cos square theta is equal to, yes, cos square theta plus sin square theta is equal to, it is 1. Yes or no? Cos square theta plus sin square theta is equal to, it is 1. So is equal to, it is Q square m upon 2C. Because what is value of this answer? It is 1. So it is Q square M over 2 CQM, that is maximum charge on capacitor, 2 that is 2 and C that is C. And yes, in this equation there is no T, no time. See, UE is function of time, UB is function of time, but total energy U, QM square upon 2C, no time, means it does not depend on time, means it is constant, means it is constant. Clear about this? So yes, it is one important question. It is one important question that you have to remember. That you have to remember. Clear about it? Now next questions from exercise. See, a resistor having 100 ohm resistance is connected to 220 watt supply, 50 hertz frequency. You have to find what is IRMS and what is power. Yes, how to write this data? 22 watt means it is VRMS. VRMS is equal to 220 watt and F is equal to it is 50 hertz. Okay, first question, that is IRMS. IRMS is equal to VRMS upon R. Simple. For only resistor circuit. For only resistor circuit, IRMS is equal to VRMS upon R. For only resistor circuit, what is power? Yes, power P is equal to it is VRMS IRMS, because cos del is equal to 1. Yes or no? That we have discussed. Okay. So yes, IRMS is equal to VRMS upon R and P is equal to VRMS IRMS. Simple. Exercise 7.2. Maximum value of voltage 300 volt and you have to find RMS value. So this simple question, we know that VRMS is equal to it is Vm upon root 2. Simple. Second question is IRMS is equal to 10 ampere. Then what is Im? Means peak value or maximum value. So yes, again IRMS is equal to Im upon root 2. So therefore Im is equal to root 2 IRMS. It is root 2 IRMS. Simple. Okay. Next one. Yes, what is next question? Exercise 7.3. Inductor having inductance L is equal to 44 millihenry. So yes, it is 44 into 10 raised to minus 3 Henry. V RMS, it is 220 volt and frequency F is equal to it is 50 hertz. Frequency F is equal to it is 50 hertz. So your question is what is IRMS? See, first of all, whenever you are given inductor or capacitor, first of all find inductive reactance or capacitive reactance. So here, first thing that you have to find, that is XL. And XL is equal to it is omega L. Is equal to it is 2 pi F. 2 pi F, that is 50 and L, that is 44 into 10 raised to minus 3. Now you find IRMS. That is IRMS is equal to VRMS upon XL. VRMS upon XL. First of all find XL and then put in this equation. Okay. So yes, it is question based on inductor. First question based on resistance. Second question which is based on inductor. Now third question, yes, it is based on capacitor. Yes, it is based on capacitor. One capacitor having capacitance 60 microfarad. 60 microfarad means it is 60 into 10 raised to minus 6 farad. Is supplied to 110 volt 60 hertz. Means VRMS is equal to 110 volt and frequency F is equal to it is 50 hertz. Okay. You have to find IRMS. So again, first of all, I will find XC, that is capacitive reactance, and XC is equal to 1 upon omega C. So XC is equal to it is 1 upon 2 pi FC. 2, that is 2 pi, that is pi F. You are given 60. Sorry, F is 60. Yes, F is 60. And C is given 60 to 10 raised to minus 6. Now you find IRMS, that is IRMS is equal to VRMS upon XC. So see difference. IRMS, VRMS upon R in resistor circuit. IRMS is equal to VRMS upon XL in inductor circuit. And IRMS is equal to it is Vrms upon Xc in capacitor circuit. Clear about this? Okay. Now next question, exercise 7.5. In exercise 7.3, this one, and exercise 7.4, this one, need power over a cycle. Yes, we know that in inductor circuit, see, in pure inductive and pure capacitive circuit, phase difference between V and I is plus or minus pi by 2. Yes or no? And yes, therefore cos pi by 2 it will be 0, and therefore average power over a cycle P is equal to it is 0. And yes, this point we have discussed in theory of average power in AC circuit. Yes, we have discussed. Okay. So yes, this is one question based on this. So yes, 4 questions, simple. Okay. 5 questions. 1, 2, 3, 4, and 1. Now next question. Yes, next question. Okay, see what is next question? Exercise 7.6. You have to find resonant frequency and Q factor. And you are given LCR, L 2 ohm, LC 32 microfarad, R it is 10 ohm, R it is 10 ohm. Okay, so yes, how to find resonant frequency? What is resonant frequency? Yes, first question, resonant frequency. Resonant frequency. Yes, the resonant frequency omega 0 is equal, it is 1 upon under root LC. Yes. You are given value of L and you are given value of C, and you have to find. Simple. Yes, it is simple. Okay. Second question, you have to find Q factor. What is equation of Q factor? Yes, Q factor is equal to this 1 upon R under root L upon C. It is 1 upon R under root L upon C that we have obtained. So simple. This question is again simple. Exercise 7.7. Capacitor having 30 microfarad capacitance and 27 millihenry inductor, they are connected. Then what is angular frequency? Yes, it is 30 into 10 raised to minus 6 farad. It is 27 into 10 raised to minus 3. Okay, you have to find angular frequency. So angular frequency omega 0 is 1 upon under root LC. Simple. Omega 0 is equal to is 1 upon under root LC. L is given, C is given. You have to just calculate. Okay. Next question, exercise 7.8. Initial charge on capacitor in exercise 7.7. Means this capacitor C is equal to, it is 30 microfarad. Means it is 30 into 10 raised to minus 6 farad. Initial charge on capacitor in exercise 7.7 is 6 millicoulomb. Means initial charge means Q1. Remember Q1. It is 6 millicoulomb. Means it is 6 into 10 raised to minus 3 coulomb. The total energy, yes, we have obtained equation of total energy in example right now, okay? So yes, it is total energy. Total energy. What is equation of total energy? U is equal to this QM square upon this QM square upon this equal value of QM. C, yes, you can easily find. And next question is, then what? Means, what about energy after some time? Energy remains constant. Total energy remains constant. Total energy remains constant. Yes, that total energy is constant. Clear about this? So yes, simple questions in exercise 7.1 to 7.8. They are simple questions. You have to calculate each and every answer. So yes, in today's lecture we have discussed about 4 illustrations and 7 exercise questions. Sorry, 8 exercise questions. So 8 and 4, 12. So it's 12 questions. You have to calculate.